Okay, so we're gonna do 2.3. Let's go ahead and look at the homework. So as I was saying last time, first thing you should try, just plug it in, see if it works. So number one, if you plug in -3, it'll just cube the -3. -3 times -3 is 9, times the -3 becomes -27. That's it. There's nothing to do. Since there's no issues with this value, just plug it in. It's nothing to really do, honestly. Now, so the first two, all they did is plug it in. So what the way you would write it on the exam would be just simply first step, plug in the -3. So over here, you'd have -3 cubed. That would be the same for question 1 and 2. Now, there are different techniques to find the limit. Last time we talked about plugging in numbers approaching from both directions, and then we also talked about graphing them. So 1 and 2, same approach. Plug in the 1 right there and right here. You should end up with 1 up top and 1 squared plus 2, which is 3, which gives you the 1/3. Again, no problems plugging them in, so just plug it in and see what happens. Okay, same thing with number 3. It begins to change here. Number 5. Let's find the limit as this function approaches -3. So you can see right away, if I plug in -3, I get division by 0, right? You see that? So you would have to actually use a new technique, which is the analytical technique or just algebraic, which we'll do on paper. We'll write this guy down. So this is 2.3. You got the name of the section. Yeah. Evaluating, and I'll switch over in a moment. Evaluating limits. Okay. The first example. Is number 5. So find the limit of the function as the limit of x approaches -3. X squared minus 9 over x plus 3. All right, so let me switch over. All right. So right here, what you would do is to keep writing the limit until you take the limit. So every step you write this guy here. Okay. Now what I'm going to do is factor the top. So you get x plus 3 times x minus 3. Factoring the top is just the difference of squares. So now these factors will cancel, which will let me plug in the -3. So once you take the limit, you stop writing it. So right here, I'm going to go ahead and plug it in, giving me -6. So when you're able to do this, is also called a removable discontinuity. So I was able to cancel it. So I'm filling the hole that was originally there. That makes sense. The first one. Any questions on number 1? Let me know. Okay. Number 6, then we'll move on. Is the same deal, except it's a difference of cubes. So you would factor this using the cube formula, canceling the x minus 1, and then you plug in the 1, x approaching 1. This bottom part, see as a simpler function, that's what's left over here when we cancel the x minus 3. So the new function part is part A. Part B would be this guy. This is the leftovers. Nothing crazy. So you do the same thing here. Whatever's left over on top, which is the quadratic part of the difference of cubes, will be this. Number 7 is showing you step by step what I just did on paper. So they just want you to fill in the blanks. So instead of just solving it on paper and plugging in the number, you plug in each step as you go. So sometimes these can be annoying, but it helps you see the process. Let's do number 8, I guess. Just for the practice. Example 2. Find the limit. So the function that we have is x cubed plus 4x minus 21. Oops, x squared, sorry. There we go. Minus 21 over x squared minus 9 as x approaches 3. So right away you should see that if I plug in a 3, let me switch back. 3 squared is 9, 9 minus 9 is 0. So division by 0 will happen if I take the limit. So what you got to do is factor. So that's what they mean by solving limits, analytically. Keep writing the limit notation until you take it. So on the top, this factors into, what is that? What does that trinomial factor into? Do you remember, Joe?
Yeah, 7 and 3 would be positive 7, negative 3.
Yeah. So that'll give you that plus 4, right? Okay, and then the bottom's the difference of squares. So that'll be plus 3 minus 3. Okay. No, I see there's a component thing here. So these cancel. That would be a removable discontinuity that we'll talk about later. So we have, this time I'll show more steps. The limit as x approaches 3 of x plus 7 over x plus 3. So take the limit. That would be 3 plus 7 over 3 plus 3. So once I do it, I shouldn't be writing the word limit. It's going to be 10 over 6, which reduces to 5/3. Okay. So part B is the simple form. I don't know if they asked for it. Let's see. No, they didn't. It's for good. But that's pretty much it. So when they say solve it algebraically or analytically, they want you to factor and cancel terms. Figure out a way so you can plug in the limit. If you can't plug it in at first, check, is there an algebra technique you can use to allow you to plug it in? And if not, then you use your graphing technique or approaching the limit with your calculator, plug it in really close values on the right and left of that value. Another technique that's also under the analytical category is number 9. This guy requires you to do conjugate. So you're multiplying by the conjugate in order to square the top and hopefully cancel the x minus 3. So whenever you see a square root, you should try this technique that we're about to do. So let me write that guy down. So find the limit. As the limit x approaches 3, the square root x plus 6 minus 3, x minus 3. So as soon as you see that square root, let me switch back. So use the conjugate technique or multiplying by the conjugate. So the conjugate of the numerator. So all that means is the same thing, but with a plus on it. So multiply this guy by the conjugate. There we go. So multiply the top and bottom by that conjugate that will square the top. So this is essentially creating a difference of squares right here. You can multiply it all out, but it's going to cancel anyway. Who cares? So this will become, if you use your difference of squares formula, instead of multiplying it all out, you get the first term squared minus the second term squared over x minus 3, x minus 3 times the square root x plus 6 plus 3. All right. So this should give us something that will cancel. So the top will become x plus 6 minus 9 over x minus 3. See how it cancels the root? This becomes a 9. Now we can hope that, yeah, this will cancel the x minus 3 in the next step. So don't multiply anything until the final step. All right. So the top will become x minus 3 over x minus 3 times this conjugate piece. So these are gone. So the whole point of the conjugate that we introduced here is to force the top to square itself with the difference of squares, then hope that we can cancel the problem term down here that was not letting me plug in 3. So now it's gone. So I'm able to take the limit. So plug in the limit. That'll be the square root of 3 plus 6 plus 3. The square root of 3 plus 6 is 9, 3. So this becomes 1 over, well, I guess we can show the work. Done this far. This will become 1 over the square root of 9 plus 3, which is 1 over 3f. 3 plus 3, 6. So you can't take the limit until you introduce this conjugate. Okay. If you see a square root plus something or minus something, multiply top and bottom by the same thing but opposite sign. So if this was a plus, use a minus here. Are there any questions on example 3? All right. Number 9 and, or sorry, number 10 and 11, and I think 12 as well, use a specific formula. There's a formula that's created by the squeeze theorem. So if you saw the videos on the theory or read the section, they'll have that formula. So I'm going to give it to you, and then we'll apply it. Let me write down the, yeah, let's go and write this note here. Come back to this. The limit of sine theta over theta as theta approaches 0 is equal to 1. That's an ugly theta. There we go. All right, so that's the main one we're going to be using. And this is created by the squeeze theorem, but I'll let you read about it if you choose to, or watch the theory videos. Example 4. So notice right here, it's almost that formula. So you got to force it to look like the formula and then apply the limit. So there's a couple ways to think about this. Find the limit. So you may have to use some of your pre-cal, who knows, depending on how complex the question is. All right, so the formula says, if this angle is exactly the same in here and down here, they have to be exactly the same, then it's equal to 1. Here, it's not a 3x, it's a regular x. This needs to be changed into an x. So there's some property of limits that I'll send you in a little bit. One of them says you can pull out a constant. So you have some constant c times your function, then you can pull out that c in front of your limit. Okay. So I can pull out this 1/3. There's a list of properties for limits. I will send that via remind tomorrow, if not tonight. So now it's exactly like the formula. So this piece will go to 1. So we get 1/3 times the 1. So apply your formula. That's it. So you're trying to kind of rig it to look like this. So whatever is in here inside the theta, it has to be down here. And vice versa. Let's do another one. You guys cool on number 4? So let me know. 11 looks more weird. Let's do that one. The limit of cosine 3 theta times tangent of 3 theta over theta. As theta approaches 0, what is that going to be? Okay. So you're going to use your trig identities to help you out because I need to make it look like this. So change this the tangent. So this tangent will become sine of 3 theta over cosine of 3 theta. The definition of tangent is sine over cosine, right? From your trig class. So these cosines will cancel, leaving me with the limit as theta approaches 0 of sine 3 theta over theta. So I can't take the limit yet because it needs to be exactly the same. So I need a 3 down here. So purposely introduce a 3 and you'll be good. So what I'll do is multiply the top and bottom by 3. Getting me to here. So this piece right here will go to 1, leaving me with this 3. You can also pull the 3 in front. That's more appropriate. And then apply the limit here. So this becomes 3 times 1. You see how, see the main idea, right? Trying to force it to look like that formula. Here we had to use some pre-cal stuff. And then some fraction idea. Once these were the same, the arguments and the quotient part, then we're good. We'll leave the rest to you. And let's leave the rest of the time for homework questions. We'll stop the lecture here.